Okay, I want to take a separate video just to focus strictly on percents in lesson 2-4 math 1270 because these story problems are going to be working with the um, percent proportion like I talked about in the previous video, which is also the same thing as using the percent equation, which you take your percent times the of, um, as long as your p is your decimal. Um, what I want to enforce here with, I think the percent equation is a little bit more efficient, but you can decide that for yourself. But something else that I need to also mention that I did not tell you yet is percent increase and percent decrease formula. So the percent increase formula is going to be your new minus your old divided by old. Okay, so and percent decrease will be the other way around. So you do your old minus new divided by old. And I'll prove that this formula works and connect it to with the percent equation to show you that it is the same thing. But the thing the easy way is it's very simple to memorize this formula because you always divide by old, one, and two. All right, I know you might get confused about the order, but the order is just going to be always has to be positive. So you just take the biggest number minus the smallest. So when I come down to this one, 4 is decreased to 1. I'm going to do 4 minus 1 because you always just want to subtract the two. You're going to have two numbers. It's going to start at a number and go to another, whether it's increasing or decreasing. But you always want to have that top number be positive. Now, if you want to look at an increase, it starts at 5 and goes to 8. So 8 is technically the new one since that's what it goes up to. And then 5 is the old. Okay. Now, when you look at the decrease, it starts at 4 and goes to 1. So now 1 is the new, and 4 is the old. Okay, so the original. Now, when you do this, you get a fraction, but in order to get the percent, you actually have to divide those two, and then move it two places to the right, which is 60%. Now, if I want to connect that to the equation or use the equation to prove, okay, is this correct? What does that really mean? That's a 60% increase. Um, um, so to do that, you're going to take, the increase is 3. So if you take 60%, okay, using the equation, so 60% as a decimal times the of, okay, what do you get? All right, well, 60% of 5 is your 3. So you increase by 3. So that's just a way to use the equation to check your work. You can also use the equation to try to solve this if you want, this equation. Just try to solve it. But I think the formula is so much easier. So I wanted to give that to you. A little bit more efficient. So here we got 3/4. That's an easy decimal. 0.75, so it's 75% decrease. Okay, so the decrease here is 3. So again, if you wanted to use the equation, what is 75% of 4? Okay, what is that? Well, then that is 3. So you decrease 3 or increase 3. But that is the way to come up with the percentage of increase and decrease. Now, if we want to move on, so memorize those formulas. The top number is always positive, and they always divide by the old. Now let's move into some real life scenarios here. Again, using the percent equation is more efficient. So you have a jacket for $135 and the sale price is $60.75, and you want to figure out the decrease. So again, we can use the formula, and you always want to make sure, all right, the top number's got to be positive. So biggest number minus smallest number. Okay, and always divide by the old. So the old is the original price is the same thing as old. All right, so then the new price is $60.75. So once you, again, this here, since it's going down, that's why it would be a percent decrease. And if I subtract that, I get 74.25. And then you can divide it. And get your decimal, and move it 2 places to the right to get your percentage. So it's 55% decrease. And you can always check that by saying, okay, well, if you take what is 55% of 135, okay, well, that's going to be your 74.25. So it decreased by $74.25, which is also saying 55% of the original price. All right, a couple more here real quick. This one here is asking for how much do you pay total. Okay, and the key thing is here we got two percentages. One is related to tax. Okay, well, tax is an increase onto your price, and a discount, okay, is a decrease to your price. So if you buy a jacket for 40 bucks, but you get a 15% discount, okay, you want to figure out what 15% is of the total price. All right, so we want to see what, and then that just tells you how much you save. Okay, so you got to do a little bit more than just say, okay, well, your answer is $6. No, this is just a discount. Very important. So with this problem, you got to, well, if you're going to save $6, you got to take that off the original. Realize that now you're down to $34. Now, something else to consider is that when you talk about tax, tax is not on top of the $40. Okay, tax is on what you're actually paying. So you don't want to take 5.25% of 40. You want to take 5.25%. Okay, we'll move this over here. Again, kind of make it a decimal. You want to take it of the $34. And once you do that, you are not done. You have to finish that by saying, okay, well, this is an increase, right? Because it's tax, so you need to add that dollar. Okay, we're going to have to say that's 79 cents, but for money purposes, right, to the nearest hundredth. So now you actually pay $35.79. So just wanted to give you that problem to reinforce discounts. You're going to subtract, and tax you're going to add that on top of. So after you figure out the percentage, you have to do one more step. Okay, take it off, and then here of tax, you have to do the one more step of adding it back on. Now they get a little bit harder because if you had to actually figure out the price. Okay, with this one, I'm going to come up with another one on top of this one too. But with this one, you actually have to work your way backwards, and you have to figure out what was the original, right? So now they're telling you what you paid versus that's what we actually solved for last time, right? We actually wanted to see how much do you pay, and we actually figured that out. Now they're actually telling you how much you pay. So what was the original price of the jacket? Okay, so to set up this one here, you have to use a little bit of, you have to set up an equation, right? Which is what you want to know, right? You want to know the original price, right? But since you know you paid 40 bucks, okay, we say, well, how do we get to that answer? All right, thinking backwards. Well, we would take our original price, okay, and we get 18% off. All right, so that's a discount. So that's going to be a subtraction off the original. So then you would just have to, well, what expression represents the discount? Okay, well, 18% of the original price. Okay, so if you take, well, once we figure out this answer, I'll plug it back in and bring it all together. But those are just like terms. So we just simplify 1 minus 0.18, and we get 0.82x. Okay, and then divide 40 divided by 0.82, and then that's going to be $48.78. So if I want to take that back, you say, well, so this is the previous problem, right? So if you know you have $48.75, you're going to get 18% off of that price. So you take that times 18, and you're going to get $8.78. So then how much do you pay? Right, you just take your $48.75, and you would have to subtract that off. Okay, some rounding errors here. Okay, but then you would have your $40. Okay, I know that this is going to be off by 300s, but again, I was rounding before, so this is just I know it actually comes out to $39.97, but that's just a rounding error that I was making back here. Okay, but that would just prove the fact, okay, the original's $48.78, so you want to work your way backwards. Now, if you were told that's a discount, what if you said you know you paid, okay, for a car, including tax, right? Because tax is an addition. So you paid for a car including tax. Okay, so walking out the door, you had $13,450. Paid $13,450 for this car, including the tax, which I'm going to tell you the tax rate was, 5.25%, something like that. So what was the cost of the car before tax, right? So cost of car, okay, before tax. So that's kind of the same idea, having to work backwards and having to set up an equation. So but instead of it being a subtraction like we did before, it's an addition, right? Because here was a discount, so you took your original price and subtract off the discounted, okay, versus here, right? You would take your original price of the car and you would have to add in the tax, okay? Well, the tax is going to be 5.25% of however much the original car is, and we know that's going to be $13,450. So same idea, same thing. It's just that you have to add this time. So just pay close attention to tax versus discounts, and then take it from there. Now, once we divide this, we will have the answer. So we'll take that real quick. 13,450 divided by 1.0525. So we have 12,779 and 9 cents. Actually rounds out to 10 cents. Okay, so again, rounding there. But that would be the price, okay, before they added the 5.25% tax. So if you wanted to check your work, okay, all you would have to do is times this by 0.0525. All right, call that A, just to save some time. And then you just have to take this and then add it to the original amount, and that's going to give you $13,450. All right, so I just wanted to go a separate lesson just talking about these specific percentage problems in more detail, as before they were a little bit easier. So try a couple of these story problems.